So we just got done graphing the trig functions. Here we're going to graph the inverse trig functions, okay? So to graph an inverse function, you switch X and Y. You're reversing the input and the output. We've done this before. We're just now going to do it with trig functions. As a disclaimer for this lesson, I am never going to have you graph one of these on a test. The sole purpose of us graphing them is so you can get a visual understanding of what they are. And the huge takeaway is, where is the range for each of them? Because what we're going to do next time is evaluate these. And you have to know what quadrants your answers will land in. So the range is the huge takeaway, okay? And I actually could just tell you the range of sine is this, the range of cosine is this. But I like to go through and show it to you visually because then you'll understand it better. Does this make sense? All right, so we're just going to take a day and graph them. You'll be all right, okay? Every year, everybody's fine. So for the trig function, this means that the input is now the sides of the triangle. Remember triangles? Okay. And the output is now the angle. Do you remember how we inputted the angle like pi over 3 or pi over 6 or 2 pi over 3? I saw you looking at your unit circle. That's coming up, all right? Like, do you know how that was the input? Pi over whatever. And then the output was the sides, like 1/2 or square root of 3 over 2. Now that's just reversed, okay? So we're going to graph each of these, and they're going to involve domain restrictions to ensure that they're functions. They have to pass the vertical line test. That's what we're going to use the highlighter for. So we're going to highlight the parts that will be restricted to, and then find the quadrants where they belong and state the domain and range. So down here, instead of filling in for X, we're going to fill in for Y because it's going to be backwards. And we're going to do our unit circle angles. So 0 pi, pi over 2, pi, 3 pi over 2, 2 pi. So just going around your unit circle. And here, I'll draw one on the board so that we have it. You can look back at that, okay? How do we get sine values? Y, okay, start with the first one. What's the Y value? 0, and then let's go around the circle. What's the next one? 1, 0, -1, 0. Beautiful. So now we're going to plot those. Bless you. So you're going to start, bless. So you're going to start with 0, 0. So we're right there. And then you have the point 1, comma, pi over 2. And I have this all nicely laid out for you. So 1 pi over 2 is going to be right here. And then 0 pi is going to be right here. It's the point 0, comma, pi. And then -1, 3 pi over 2 would be right here. And then back to 2 pi. So what do you notice? Good. That ain't right. Should be like one of the things that you're like, hey, hold on a second. But what else do you notice more about the shape, I should say? It's just sideways, right? Like it's a wave, but it's sideways. Like if you turn your head, do you get what I'm saying? All right. Now what you want to do is keep the pattern going. So look, we waved this way, like to the left and then to the right. Now, where's the next point going to go? To the left, it'll be right here. And then back to the center. And so on. I feel like it looks like a double helix. Do you know what I'm talking about? Like a DNA strand? Yeah, like draw more to, yeah, I don't know. That's what it always looks like to me. Like in my mind, that's what I see. But I said, what do you notice? And you said, that's not right. That should be the first like reaction. Do you get that it fails the vertical line test? So it has to be very, very, very restricted. And that's what the highlighter is for. Now you always take the part that's in quadrant 1, and you're going to have to really listen to me explain this. This is not quadrant 1, 2, 3, 4 anymore. Okay. Do you see how this is labeled? How this is 0 pi and then this is pi over 2? So this section right in here horizontally represents quadrant 1. Quadrant 1 is represented by this little strip of space here. And then do you see how this is pi over 2 and this is pi? From pi over 2 to pi is the second quadrant. So this little strip of space here is the second quadrant. And then this would be 3 and this would be 4. Now, if you go backwards, if you're between 0 and negative pi over 2, think about here's 0 pi, here's negative pi over 2. Which quadrant is that? Where you're negative, it would be quadrant 4, and then this would be 3, 2, 1. I'm not going to write that on every single one of these. It would be the same for all of them. But you always start by highlighting what's in quadrant 1. So you always take quadrant 1. So that's this part right here. Then you want to see if you can go into quadrant 2. So it's a yes or a no. If I keep this highlighted part, can I also keep what's in quadrant 2, this part right here? Why not? It'll fail your vertical line test. Now listen carefully. If you can't get to quadrant 2, you also can't get to quadrant 3 or 4. If this part's missing, you can't go any further. It's like there's a big void there, so you're stuck. So if I can't go any further that direction, can I go any further this direction? Yes, you can get a little bit further, which is into which quadrant? 4. Good. You rotate backwards, you can go into quadrant 4, and then can you go any further than that? No. This little part that I highlighted orange, or you highlighted whatever color of yours, that's the whole graph. The rest of this we get rid of. That little thing, that's the whole graph. For sine inverse, with me? Okay. So let's write the domain and range. So domain is left to right. What did we get for our domain? Look, left to right. -1 to 1 with, oh my gosh, that was the range for sine. Now it's the domain for sine inverse. Crazy. All right, and then your range, we're going downwards to upwards. So starting where? Where is this down here? Negative pi over 2 to positive pi over 2. And then this is the huge takeaway. This is like the main point of the whole thing. If you forgot about the rest of it, if it was like too long, didn't read, this is the part you need to get. It's in quadrant 1 and 4. The range of it is in quadrants 1 and 4. Because what I'm trying to gear you up to, maybe highlight that too. That's the really important thing. Because what we're going to do next time is evaluate these. And for sine inverse, you can only get answers in quadrant 1 and 4. That's it. The rest of them don't exist. Okay? And this is the reason why. Because I could have just said it's only in 1 and 4, but then you'd be like, why? Like you wouldn't understand why. And this is the reason why. All right, let's do sine inverse. Again, we're going to plug in for y and get x. So go and put in your unit circle values. For y, again, it's backwards. And we're going to go around our unit circle and evaluate how do you get cosine values? X, good. So starting here, what's your first x value? Good, 1. And then what's the next one? 0, -1, 0, 1. And then you're going to graph it. Guess what? It's going to be a wave, but it's just going to start in a slightly different spot than the one that we just did. Okay. So you're going to start by plotting this point, 1, 0. So that'll be right here. So instead of the origin, it starts at 1. And then 0 pi over 2 would be right here. And then -1 pi would be right there. And then I'm going to stop reading them because I know that's annoying. Just keep on going. Now you want to keep the pattern going. Where would the next point be if you kept the pattern going? Zero, -pi over 2 would be this one right here. And then you'd have -1, -pi, just keep it going. You want to fill in the whole space. I always have to turn the paper to connect it though, like I struggle with that. And I like what you said, that ain't right. I'm gonna steal it. Your first reaction should be, that ain't right. Like it fails the vertical line test, it's not a function. So pull out your highlighter, we're gonna highlight the parts we get to keep, and you always start with quadrant 1. That's the first little like strip of space there. And then you want to see where else you can go. What other quadrant could you go into? Quadrant 2, do you see how we could keep going here and go into quadrant 2? Why couldn't you go into quadrant 4? Like go backwards and get this piece of it. Fails your vertical line test. Can you keep going here? Get any further? No, this is the entire graph. The part we highlighted, that's the whole thing. That's all you get to keep for sine or for cosine inverse. So let's do our domain and range. And then list what quadrants we were in. So domain is left to right. That would be where to where? -1 to 1. Range is downwards to upwards. So where are we starting? 0 pi, and it goes up to pi. Good. And here's the big takeaway, and this is the whole point. What quadrants is cosine inverse in? Quadrants 1 and 2. Bless you. So maybe like highlight that as well. That's the most important part. This is like your huge takeaway. I'm going to say one other thing and then we'll do our little break. There's 2 ways that you can write an inverse trig function. One way is with this little -1. The other way is with arc. So if you see arc sine of x, these mean the same thing. Write that down because they're interchangeable. And sometimes you see with a little -1 and sometimes you see it with arc. They mean the exact same thing. Same thing with cosine. You could see this as arc cosine. I kind of prefer the arc. I feel like it looks a little cleaner and fancier. I don't like the little -1 because it tends to confuse people. So I prefer arc, but they are interchangeable and it just means inverse. We together there? You don't like which one? Oh, like there's more letters, like the word is longer. Well, you're allowed to have your opinion. The reason I don't like this is because as a teacher, like my students get confused by the -1 sometimes, and that I don't like when my students are confused. So anyway. All right, so now we're gonna do cosecant inverse, which could also be written arc cosecant, just so you know, it means the exact same thing. And again, go ahead and put in your unit circle values. So when we go around this circle, how do you get cosecant? 1 over y. Good, we're going to flip all the y values. So look at your first y value is 0. You can't flip 0, so that would be undefined. What does that mean in the graph? Remember how before it was vertical? Now, I know. See, you guys are so smart. All right, pi over 2. Now we're at the top. It's 1. If you flip 1, that is 1. Could you keep the pattern going? What's the next one? Undefined, and then -1, good, and then undefined. It's gonna look like the cosecant graph sideways. Okay, so at 0 pi, you're gonna have an asymptote. That's gonna be this way. I know that's hard to see because it's on the axis, but be like that. So sideways. And then you have the point 1 pi over 2. So that's gonna be right here. And then another asymptote. And then -1, 3 pi over 2, and then another asymptote. I always try to draw mine fast so that you guys can see it. So hold on a second, because I can't draw it, like I have to move the paper to do it. So it should look like that. And once you draw that, you want to keep the pattern going the other direction. And you could even turn your paper, turn your paper this way to draw it, because then it'll look like the regular function. And again, I'm gonna just hold there for a second to give everyone a chance to draw it. I drew it kind of quick so that you could look at mine, but you are gonna have to get out your highlighter and we're gonna have to highlight certain pieces of that because again, you only get to keep a very, very small portion of it. Here, I have another one. Here.
You got the low eye. You got a low IQ. They just started that. You couldn't give me until like it's not a half hour.
Stop bickering.
He's in my for almost an hour.
All right. Did we all get that drawn and we're gonna highlight it now? So you always start with quadrant 1. So you're gonna start with this piece of it. So that's the first piece that you get to keep. And then you figure out where else you can go from there. Can you go into quadrant 2? No. That means you can't go any further. Because some people would be like, well, I could highlight this part. No, you can't. If you can't get into quadrant 2, you can't get into quadrant 3. So you're stuck that direction. Now, could you keep anything in quadrant 4? Like, could we keep this piece? Yes. So you get that piece of it. And then that's it. So again, we're going to state our domain and range. And then the quadrants that we got to keep, because that's the big takeaway. So domain is left to right. It'll be negative infinity up to what? -1 with a bracket. Good. Union. And oh my gosh, that was the range before. Now it's the domain.
Whoa.
And then we're going to do the range. And again, it's just the highlighted part. So where do we start at down here? Negative pi over 2. Good. And that'll get a bracket. Negative pi over 2. And as I'm sweeping upwards, I have to skip over. Why do I have to skip over 0? There's an asymptote there. So it'll be to 0. And then 0 all the way up to pi over 2. So you want negative pi over 2 to positive pi over 2, but you have to leave out 0. Do you remember the rational graphs when we left out the troublemakers? Yeah. It's like 0 is a troublemaker. All right, and the quadrants that we got to keep are 1 and 4. And again, if you didn't understand anything else I just said, that's what you need to get out of it. Okay, I do this as a whole explanation of why that works. But at the end of the day, as long as you understand this, then you're going to be fine. Okay. Now, when we do secant inverse, or again, you can also write it arc secant, means the same thing. It's going to look remarkably similar, just start in a different place, but you're going to get all those U shapes. So go ahead and put your unit circle values. And again, that's for Y. All right, so how do we get secant values from this? We're doing secant now. How do we get secant values? You're going to flip what? You're going to flip X. Are we all back together here? All right, what's your first X number? 1. If you flip 1, it's 1. How about the next one? Now we're up at the top. The undefined. Good. -1, undefined, +1. And then we're going to go ahead and plot this. So your first point is 1, 0. So that's going to be right here. And then an asymptote. And then -1 pi. And then another asymptote. And you want to just keep the pattern going. And sorry, I'm trying to draw mine quick so you can look at it. And so again, we're going to pick what parts we get to keep because you get to keep precious little of this. You always start with quadrant 1, which would be this part, that first little like strip of space there. And then you need to figure out which other quadrant you could go to. Could you go down here to 4? No, that means you can't go backwards any further. You're stuck this direction. So could you go forwards into quadrant 2? Yes. So we're going to keep this part. Again, it has to pass the vertical line test. So we're keeping only the parts where you would pass the vertical line test. Oh, good. You're already ahead of me. So domain left to right. And we're just looking at the highlighted part now. It'll be negative infinity to negative 1. Union 1 to infinity. Same as cosecant inverse. And then your range, you're going to sweep downwards to upwards. Again, look at just the highlighted part. Where are we starting? We're starting at 0 pi. Good. Now look, you want to go all the way up to 1 pi, but what do you have to leave out? Like who's your troublemaker where this asymptote? Pi over 2. So it's going to be 0 pi to pi over 2 union pi over 2 to pi. So you're going from 0 to pi, but you have to leave that out because there's an asymptote. And so again, here's the big takeaway, like the thing I need to make sure you understand. What quadrants is arc secant in? 1 and 2. So like that's the big point of the whole thing.
Did you break something?
All right, go ahead and flip over. Now we're going to do arc tangent. See, tangent inverse, this can also be written arc tangent and arc cotangent. So I'm going to need to add something to this circle up here. What do I need to put up here? Because these two are different. Yeah, like your little rest stops here, right? So square root of 2 over 2. And then this one's negative. All right, so when you go and put your values in, and again, we're putting in values for y and we'll get x. You're going to start at 0, but you only want to go to pi. So we're going to have to, instead of breaking down by halves, by 4. Perfect. Good. You guys are good with the fractions. So this will be pi over 4, pi over 2, or 2/4, and then 3/4, and then a whole pi is 4/4. Because we're only going halfway around the circle. How do you get tangent values? Y over x. Good. All right, look it. Don't lose focus. We're almost done here. The first one would be 0 over 1, which is 0. Good. Now, if you go to that first little rest stop, I know it's square root of 2 over 2, but anything over itself is 1. And then up at the tippy top, it's 1 over 0, which is undefined. And then what do you get for this one? Negative 1. Good. Anything over itself is 1. It's just negative, and then back to 0. What do you think it's going to look like? Yeah, like the wiggly things, but sideways. Okay. So you're going to have a point at 0, 0. Now, 1 pi over 4. Pi over 4 is going to be halfway in between here. So that point is going to be kind of like floating in the middle. Do you see that there? Because again, a 4th is half of a half. Thank you for heads nodding. All right, and then an asymptote. And then -1, 3 pi over 4. Again, 3/4 is going to be floating in between. So that point is like in the middle there. And then back to 0. And again, I'll try to draw mine quick so I can tilt the paper back up here and you can all see it. But it's going to go -1, 0, 1. Asymptote, -1, 0, 1 asymptote, and you can keep that pattern going. I'm not trying to rush, but you don't need to be a great artist. Like it just needs to be good enough. Are we without running around the room? I don't know where everybody's at. Are we okay? So now we're gonna highlight the parts you get to keep. You're always gonna start with quadrant 1. And now here it's kind of debatable which direction you would want to go. So I'm going to just go ahead and tell you that we're going to also take quadrant 4. It's going to be this part. So 1 and 4 that's the big takeaway. And I'm going to sum this all up at the end. So when I finish this last graph, don't stop listening to me because I'm going to do like a big conclusion and then let you know what your assignment is. All right, so what's domain for this? Left to right? Yeah, all reals. And oh my gosh, that was the range before. Now it's the domain. And then range. Again, you're just looking at the highlighted part. Sweep downwards to upwards. It's going to go from, where are we starting here? Negative pi over 2, but with a good. Why a parentheses? There's an asymptote. Good. And then up to positive pi over 2, again with the parentheses. And the point is, it's in quadrants 1 and 4. The range is. Because again, next time when we go to evaluate these, you need to know where your answers can end up. So it's the range that's important. Like where could the answer end up being? All right, last one. Again, you're going to put your unit circle values in for y. And again, it's going to count by fourths because this one only goes halfway around. And I'm sorry, let me show that again in case anybody didn't get that. So how do you get, oh, and again, this could be written as arc cotangent. I hope I'm hitting that hard enough so everybody knows that. How do you get cotangent values when you go around? X over y. So the first one, 1 over 0 is undefined. And then the next one's that square root of 2 over 2, rest stop, anything over itself, 1. Then you're up at the top, it will be 0, -1, undefined. So this one's going to start with an asymptote on 0. I know that's hard to see because it's on the axis, but that's an asymptote. You get the point 1 pi over 4. So again, pi over 4 is kind of floating in between there. 0 pi over 2. We write there. And then -1, 3 pi over 4. That's kind of floating there. And then another asymptote. And then again, you can just keep the pattern going. Whoops. What's the question? Oh, bummer. Yeah, I was super excited to get those desks because my old ones were really like crummy and they had things like carved in them. But these are like not super awesome either. I feel like they're wobbly. All right, so now we're going to highlight the parts we get to keep. You're going to start with quadrant 1. And I know this is gonna end up bothering you. It happens every year, but you're gonna have to just go with it. They have to go together. Like, do you know how sine and cosecant go together? Cosine and secant go together, the reciprocal ones. Tangent and cotangent, arctangent, arccotangent have to go together. So if this one was 1 and 4, this one has to be 1 and 4, and so it gets kind of broken like that. You're allowed to feel however that makes you feel. I know it's like, I wish we could connect this, but I'm just telling you that's what it is. I know, because everybody always wants to just keep going here, and I get it, but it has to match, so you can't do that. All right, so domain, it will still be all reals. Look it. For this part I highlighted, do you see how right here this piece picks up where that one left off? Yeah, so like left to right, you still get everything. So it's still all reals. And then range, downwards to upwards, and we're just looking at the highlighted part. Where do we start? Negative pi over 2, and we want to go to positive pi over 2, but we're leaving out 0. Good. So you're going to start at negative pi over 2, go to positive pi over 2, but you have to skip over 0. And here's the whole point. If you're like, I don't really care about the rest of that, here's the part you have to get. It's in quadrants 1 and 4. And like I said, don't stop listening to me because I'm going to sum this all up. Do you remember when we did the original trig graphs? And I gave you that little cover sheet for all 6 of them where we did the parent graph. And I was like, here's some things you notice. Do you remember how I told you which ones were even and which ones were odd? And I said, it doesn't matter today, but it's going to later. Today's that day, okay? The odd ones are sine, and so also cosecant, tangent, and cotangent. Look through what we just did. What quadrants do the odd ones land in? 1 and which other one? 4. Good. The even ones were cosine and secant. Which quadrants did they land in? 1 and 2. So that's how they're divided up. The odd ones are in 1 and 4. The even ones are in 1 and 2. And this odd and even is going to come up again next unit. So you can't be like, I'm not going to learn that. It's going to come up again. I'm just letting you know. But that's how you can tell the difference. Okay. And like the thing with this lesson is I could have just told you this and it would have taken 1 minute. But I like to show you the graphs because now you understand why. Like you have a visual, which helps. This last page, that's what we're doing next time, okay? Is we'll start evaluating that.